And then we have our kinds of rasters. So we have thematic and image. A thematic simply is a raster that contains a theme or a single variable, like elevation is a theme, roads are a theme, forest is a theme, temperature is a theme. So a theme is just one thing. Whereas an image, even though it's a continuous data type or a type of data, because it's representing in each single cell the reflectance of light in a certain part of the electromagnetic spectrum, or in multiple parts of the electromagnetic spectrum combined visually. Images don't contain a theme. They show everything that it sees. So everything that can be seen is shown on the image. And often we use, and you'll learn this if you take the remote sensing course in the third year, or concomitantly taking it right now, that we can use images to derive themes. So for example, if we wanted to derive a theme of intensity of vegetation, we could use the normalized difference vegetation index, NDVI, which takes the infrared band minus the red over the infrared plus red. So it's a ratio that creates a continuous variable or theme for vegetation intensity. And that then becomes a thematic raster layer. So these are, again, two types of thematic, and I think we've seen those already. And we haven't seen image, so this is an example of image data. And this is just a 3-band image, the same type that you would take with the digital camera on your mobile wireless cellular telephone. Here you have blue, green, and red. So the blue parts of the electromagnetic spectrum, the green part, and the red part. And these are the parts that are combined to create real color visible that we see in our eyes, for example. So these parts of the electromagnetic spectrum are measured. They can be combined to create a visible color image of the Earth's surface the way we see it with our eyes. And those values, so values of reflectance in red, green, and blue, are shown in each of the cells of the red-blue layer, the blue layer, and the green layer. Then we have raster types that are fuzzy. So fuzzy types of data. And a fuzzy variable can be created from a categorical variable or a continuous variable, but most often from continuous variables in GIS, where 0 in a cell represents no membership or likelihood in, or no membership in the class of likelihood that this particular layer would represent. And 1 represents complete membership. So for example, on this here, this particular fuzzy image, which is overlaid on a real-world visible image just for context, the green represents values near 1, and the brown, reddish over here, are near 0. And this is a fuzzy layer for the likelihood of nesting habitat for an eagle. So the most likely places are going to be in green, and the least likely in the red, dark reddish areas. And this is done or created from a fuzzy membership function, like you see here. These are sigmoidal functions. And they just have that shape, that S shape. So sigmoid is easy to remember because a sigmoid has an S shape. And we'll see these, you'll even use these in one of the exercises this year to learn more about fuzzy layers and how to combine them together to create a likelihood map. In any case, we have some value, which is measured here on a continuous scale on the number line. And then for each value, you can go up to one of the curves, whichever one you would like to use as a fuzzy membership curve, and then read off the membership value. And this is a likelihood value, 0.5 for example. So in this case, if the let's say that was distance. This could be distance from lake. In the distance from lake, we go from 0 to 20. Let's say that's a 20 kilometers, or 20 kilometers, 40 kilometers, 60 kilometers, 90 kilometers, 100 kilometers. And we've decided for some logical reason that this blue line is the best form for, let's say, determining nesting habitat according to distance from lake for this type of eagle that's represented in this raster up top. So we go from 40, for example, and then we say 0.5. So at 40 kilometers, the membership in likelihood for nesting habitat is 0.5. At 20 kilometers here, well, it's much higher. It's around 0.9. So within up to 20 kilometers, or at 20 kilometers away from the lake here, we have a membership of 0.9. And 0 to 10 kilometers from the lake, it's at 1 right here. So within 0 to 10 kilometers, we have a membership of 1. That would be prime likelihood for eagle nesting in this region. So a curve like this, blue one that you see here, is used to transform some what we call environmental variable like distance from lake into a fuzzy membership layer that goes between 0 and 1. So it's always bounded in that domain, 0 to 1. So every fuzzy variable is 0 to 1. And there can be different types of functional forms that are used. Your imagination is the limit. This is a stepwise linear function. Here's another example where we have a map A which shows the distance from observations. The observations are the points here. And every location is a cell, and in each cell there's a distance value. What we can do is transform distance from the locations into a fuzzified variable that is shown in B over here. Here, the likelihoods range from 0, which is blue, to very dark red, which is 1. That's a value of 1 there. And this data is something you'll be doing in one of the exercises this particular year. And it is the observations of kudzu, which is a highly invasive vine in the United States, and also starting in Canada due to climate change. In the United States, kudzu is a colonal plant which generally reproduces from its root system and can quickly take over and destroy an entire ecosystem, which it has done in numerous parts of the United States, in the southeast United States particularly, where you can see the high densities of kudzu in that region. Here's another type of sigmoidal function, again transforming a variable called distance from schools into a fuzzy likelihood.